Assalamualaikum warahmatullahi wabarakatuh. This video will explain about the minor losses. Minor losses is the second of energy losses. The part one, we learn about the primary losses or major losses. The cause of minor losses is the first one is pipe expansion. This is the suddenly change of the area. If you see the diameter in the pipe 1, it has D1, and the water through the pipe and the diameter will change to D2 or diameter 2. This is the expansion diameter, so it will make the energy losses, and the cause of the pipe expansion, it will make the minor losses. This formula is used to find the minor losses. We can write HE for the minor losses, and then this formula determined by the fundamental formula that we learn. It is the momentum equation and Bernoulli equation, and also the continuity equation. This is the explanation. It is the momentum equation. We know that momentum equation is the formula from the Newton's second law. This is F equals ma, or mass times the acceleration. So it has the changing of the velocity from the input system to output system. So they have two velocity, v2 minus v1. This is mass, rho times q, or discharge. And the force is in the pipe, we have P times A. It determines the pressure, and then P2 times A, it is also the force because of the pressure, and then it is the change of the area, so it has P times A2 minus A1. So if the formula all will be divided by A2 times gamma, so we have P2 over gamma equals A1 over A2 times P1 over gamma, and blah blah blah. And from Bernoulli equation, we have in pipe 1 and pipe 2, we have the total energy of pressure and pressure head and velocity head. plus don't forget to add the energy losses. And this chapter we will focus on minor losses. So the total energy losses, not all of the cows. It is the, what is it? HF or major losses, major loss. It is because of friction. We ignore it. So the formula in Bernoulli equation, it is plus HE or minor losses. From this, if we want to find HE, so HE equals blah blah blah, and then P2 over gamma we substitute with the previous formula, so we can add this, and after that we make it simple with this, and because of the P1 equals P accent, so the simple formula will be here. HE equals V1 minus V2 square over 2G. And because of the, if we want to see the first formula, because of the pipe 2 will next to the what is pool, so the velocity will 0, so the HE equals V1 square over 2G. This is the example to find the minor loss due to the expansion of the diameter. It is pipe flow, and the water through the pipe, water flow through the pipe and changes in diameter from 10 to 15. And the velocity in pipe 1 is 1.2, so calculate the minor loss. So we can find the minor loss from the formula V1 minus V2 square over 2G. So we have 0.0227 meter. Okay. The next cause is because of the expansion pipe also, but it is gradually. Gradually is because of the reduced by alpha. Alpha is the angle of the changes of the diameter. To show the expansion is gradually or suddenly. So if we see the table, so from alpha 10 degree to 75 degree, it shows that K accent it's smaller than if we have the alpha is 75 degree. So the K makes the HE or minor losses will higher also. The higher K, the higher HE. The next cause is because of the contraction. It is the suddenly contraction. We know if the water flow, if it is it has contraction after big diameter to small diameter or if we see the water flow from the pipe, so before it can fall, the diameter of the flow will have contraction, so the diameter will smaller than the pipe. So it is the vena contracta. So if we have vena contracta, the diameter is not about the diameter of pipe, but the diameter is about the diameter of the water flow. So we can use the vena contracta diameter. And from the experiment, the researchers say that AC, or area of contracta, equals 0.6 times A2. So we have HE, or minor loss because of the contraction, is 0.544 V2 square over 2G. The next cause is entrange. So if the water flow through the pipe and it has entrange, the shape or type of inlet from the reservoir to the pipe, so energy loss will happen, and it's depend on the shape of the inlet hole. Like you see, it is the pipe inlet. It is the because of the shape, the water will difficultly enter the pipe. But if the shape is like that, it is sharp edge, so the water will easier to flow. And if the changes has a radius, so the water will flow more easily. So you can see the K is 0.8 and it is 0.5, and if water easily flow, so you can see that K is 0.0, so it will make the minimum head loss. And you can see in the pipe exit also, you can see if the water will flow easily, so the KL will smaller and makes it have a minimum head loss. Okay, the next is contraction. It is get gradually contraction. It's because the pipe have angle in the changes of the diameter from the bigger area to a smaller area of pipe. So it will depend on K accent and also the alpha. And number 6 is the cause of the minor losses is bend and branches. you can see the value of KL. It is 1.1 and it is 0.2. It is because of the, what is it? It is like helper to the to flow, can flow easily. And then if you see the branch, it has radius or something to help the flow easily, so the KL will minimum. And number 7 is the close is valve, so it is fully open. If we use globe valve, angle valve, bulb valve, and so on, so it will influence the score or value of KL, so it will influence the HE or minor losses. Okay, that's all of the material about minor losses. So you can add the influence of the minor losses or ignore it. It's depend on the case. Okay, thank you. You can deeply understand with the exercise. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.